At Dave Cooper Live, we connect the industry leaders in the architectural, engineering, and construction space with the people, the products, and the processes to help them build it better. Everybody, today we'll meet the robot that uses a pick and place 3D printing technique to build structures from local waste, subsoil, converting clay into low carbon walls. Today we welcome Daniel Weddle, Chief Design Officer of Terran Robotics, and hear how they are helping to deliver extraordinary homes at dirt cheap prices. Ha! You know I couldn't resist the pun. At Dave Cooper Live, we connect the leaders in the AEC space with the people, the products, and the processes to help us all build it better. But before we get into all this fun dirt, we got to thank all of our supporting members first, and then we'll be right back with our interview. Forward Solutions Group is successfully driving companies to succeed where others have failed. Are you looking to start a factory? Optimize your existing factory, streamline your production, or take your team to the next level? Whatever your needs are, Forward has a solution for you. Reach out to Ben at forwardsolutionsgroup.com. Halleck Ltd. has a long history of innovation in cold form steel manufacturing and producing innovative precision roll forming technology for customers throughout the United States and the world. Check out their machine buyer's guide for off-site modular construction or fast build construction with light steel for framing. Go to their website, halleckltd.com. Brought to you by Greatech, one of the largest Autodesk partners globally and software developer of the PowerPack Advanced Design, Advanced Steel, and the StruxSoft product line. The complete solution to automate wood and light gauge steel framing, design, and documentation all the way out to CNC output. Model, design, and manufacture with StruxSoft. Learn more at StruxSoftSolutions.com. All right, again, thanks to all of our supporting members. We cannot bring you all these informative conversations without their support. And a big shout out to Cobalt Creed and our friend Sean Intagliata as well. Some of the best high velocity air systems you can put in your homes. Anywho, let's get into it. Let's bring Danny onto the show. Danny, how are you, my friend?
Oh, doing pretty good. Busy out here today. Excited to stay here and chat with you for a minute.
Well, you know what? Hey, listen, man, busy is good. You're on a job site, so we're going to be able to show a little bit of what you're doing out there. And out of the blue, your concrete folks decided to show up today. So you're dealing with that and trying to do a live show from Starlink, which I think is super cool. But Danny, before we get into this, we want to know everything about you from the moment you were born to this very moment in time. Do not leave out any of the good stuff from the hospital. or we'll have your family and friends on, and it'll get embarrassing. But hey, tell us a little bit about your background, and then let's get into Terran Robotics.
Well, born in the circus capital of the world. That's a fun little fact if you want something real young. Military family, Air Force. Grew up in northern Indiana, then Washington State. Moved back here, family from about an hour away. Got into the building journey doing the things that I'm sitting in here now. Cut a lot of lumber off my parents' property. Started building tiny homes on wheels. This one I actually broke off the truck about 3 months ago, moved on site. Now it's the headquarters for the engineering team. After running that company, ended up in grad school for architecture. Got a National Science Foundation grant with my business founder, Zach, during that time in school. Left about a semester early and then started this company. So I've been pushing at building affordable houses with Earth ever since, which we're somewhere a little over 5 years into.
So tell me, Danny, what drove you to want to do this? Like, where's the passion come from? To one, like you said, you started off with lumber, but I mean, did you just slept in the dirt one night and you woke up and looked at it and said, you know what, I think I can make a robot that can build stuff out of this?
It's just if you look at what you can automate, if you think about stick, half the price is approximately materials, something like that.
Right.
In the case of dirt, the materials cost something, 2-3% of the total cost. Often it's waste soil. On this side, it's literally from next door. I'm putting a pond in, that pond is becoming the house. So the ability to automate the labor, that's the highest delta. Like right. 95, 98% of the labor can be automated in this system, and then no one can beat the price. And you ask what's the driving principle behind that? Like there are kind of two forks. The things I built here, I built believing they were affordable housing. What turned out the tiny house movement was kind of a scam, and that you built something very expensive on wheels that was tied to nothing, had no equity because it wasn't foundation based. These ones are right. That way now. So that was like kind of a foray into trying to figure out how to do affordable. Small is affordable in a lot of ways. But that form of stick didn't pan out. And I was seeing that time and time again in that I wasn't building wealth for people. So doing something foundation based of materials that can be fully automated. When you look at all of the world of building materials, Earth is just the obvious answer.
Right. Well, I have a bunch of slides and stuff that I'm gonna put up here while you're speaking. Talk us a little bit about Terran Robotics, right? Turning dirt into beautiful homes is kind of one of the things you have up here in radically affordable, high quality housing. Talk to us a little bit about the company and what it is, your goals are, what your vision is, and so on and so forth.
Yeah, I mean, it's laid out there and they're pretty easily right here. Affordable housing. So if you take out the wall cost to its ideal conclusion at scale, you're getting sub 100 for the wall, sub $50 a linear foot per wall. To give that in perspective, in our region of stick, which I'm Midwestern based, Habitat's somewhere $90, $100 just for their materials, and then a good stick frame package is going to be somewhere closer to 200. So right out the gate, we're like a quarter of the cost of a comparably built sort of mid-high end commercial structure. And then you go into the next step of there, the quality housing. Earth is a fairly unbeatable in two paths. It's one material that the entire wall assembly is built out of. So you're no longer fighting places where you have a dew point in the wall. It's simple. You have 3 materials instead of 30. You take our material and take out 5, 6, 7 trades. So you're having a good conversation with the developer and you're like, hey, I'll come in and do plate to plate. The thickness of the wall and then the nature of the material means you got a lot of mass where you want to hold heat and humidity. And then the material itself is hydroscopic, which means it's always moving moisture. So it's a clean way to keep the walls at the right amount of humidity for human comfort. This last one on here is we'll get more into the tech when we look at it.
I want to touch on something. We were in Europe with the folks from World of Smart Homes, Osama Alabi and Pernilla and others over there, and I learned so much about clay. And the moisture part had me the most interested, right? Because the clay will move the moisture where it's needed versus it all getting stuck in one area. And I think that's kind of what you were talking about with the clay wall, because it'll pull moisture when it needs it, and it'll get rid of it when it doesn't need it. Correct?
Exactly. And people often will use the term thermal battery, which is true for concrete or any masonry. But with clay, it's also a hydro battery.
Right.
In our climate, you charge in the summer and you get the hydration you need in the winter. So it's a yeah.
So, so with that, where did your skill come from to figure all this stuff out? Because I mean, there's clay pretty much in every part of the world, is there not?
Yeah, I mean, pretty much everywhere, and we get the question a lot about like what percentage of clay is good.
Yeah.
In the Southwest, where they're using a lot of adobe material still, it's something like 93 to 96% of the clay in their region is still usable. And I've only tested one site here in the Midwest that wasn't possible to build with, and it's because it
Right.
was river adjacent.
Sure.
Everything else has been pretty much across the board, high quality stuff. And a lot of our data comes from partnerships with Europe, where they're studying this more heavily than we are in the U.S.
Right, right. Love it. So listen, if you guys are just joining us out there, Danny and Terran Robotics, we are on location. We are going to be able to show you the machine that they're currently using for building this house that they're in. And this is a project that Danny will be living in as well. Includes a whole lot of other features like hydronic floor heating and cooling and all of that. But so stick around for that. But let's get through this. I want to walk through your website a little bit and just give everybody a good understanding, and then we can get to all the rest of the fun stuff. Sound good?
Sounds great.
So, key ideas: tech, print and place 3D printing.
Yeah, exactly. So what you'll see today is this particular piece of the equipment. So it's what it is. It's a claw. Picks up the material, uses a
Right.
set of vision to find it, grab it, put it on the wall assembly, and then we switch tools to a linear hammer. It's basically just mimicking the same thing humans do when they're building this material. You're just patting it into place. We have a lot greater force, a lot faster movements. What's important in that is there's no layer deposition. In most 3D printed concrete or earth, you've got these tiny little layers. It works pretty well in concrete now if you add accelerants and other things, plasticizer, stuff that makes that strong. We don't have that problem. We have a
Mhm.
continuous wall assembly when it's done. So it's a lot, it's not even a lot more. It's is what people were doing for thousands of years, building one monolithic wall assembly.
Yeah, I mean, and using the basic ingredients, clay, aggregate, and binder, which people have been building with for as long as man's really been around for the most part.
Absolutely. And then I guess a little tail off of this, and this is a lot where my research is. We use lightweight aggregates that I don't disclose for company reasons, straw and clay.
Mhm.
And with that particular proprietary mix, we hit something like half weight cob, which is what makes building this way possible because our cob carries R value that other masonry systems do not. So we're not putting insulation on the outside, we're not putting it in the middle. It is integral to the mix. And that's part of the secret sauce of this system being so slick and so deployable.
Love it. And the business model, right? Are you building for yourself or are you building for developers?
What we've been offering developers is sort of a full stack solution, plate to plate. The goal is to find people, in the 10 to 100 houses a year. For next year, we've got a couple clients that each want 2 or 3 at a time. That's a nice way to start. Like our big gains happen when we have multiple machines going on a site with one operator.
Right.
That's where we like really hack up the speed.
Love it. Love it. And then the walls themselves, the product, right? They're non toxic, durable, can last for centuries, naturally sound, and fireproof. So these walls are sound and fireproof, which makes sense. We talked about the humidity regulation, but let's talk about the solar mass that you're talking about here.
Yeah, so it's 55 pounds per cubic foot of wall. That's the mass that we have to charge. In this structure we're doing here, we're doing a fairly unique system for charging it. In that, in addition to the hydronics of the concrete floor in the basement, I'm pulling the hydronics up and into the wall assembly. So I'll be charging the wall with the hot water heater that's doing an air-to-air exchange. So making high quality heat at the right time and then putting it in the wall assembly. So it's radiating. Every wall in the house is going to be a radiator. So that's when you feel comfortable, is when you got heat coming to you from below, from the side, any sort of forced air systems where you start to like feel uncomfortable because there's a point.
Yeah, for sure. And another thing that's on here that's really interesting and is gaining a lot of attention is this mentally soothing in the organic style. Last year, I was at a mass timber conference, and there was a lot of talk and a lot of studies of living in natural materials such as wood, where you can actually see the wood grain, or clay, and how important that is for not only your mindset, but for the comfort and the ability to actually relax versus being surrounded by steel and sheetrock. So there's, what's your take on that?
I think if it's speaking directly to Earth, so I would say like modern home era, modern design, we got pretty clean and we stayed
Yeah.
pretty clean. Drywall's pretty clean. You might have
Mhm.
like a small trim detail or so forth. Concrete's pretty clean as well. What makes Earth, I think, unique and what people don't really think about too much is that unlike concrete, it doesn't bounce sound. It does to some degree, but it's also like grabbing it and like holding some of it. So
Right.
you end up with like a quieter space that feels warmer, and then the overall thickness of the walls give this sort of like mass. You feel like you're in a very high end space.
Got it. Got it. Got it. And let's talk about the projects that you have, and then I want to get into your project right after this. So you guys have different projects that you work on that I'm seeing on your website here. I'm going to put it up here, and let's just walk through it, and then I want to walk into exactly what you're building today.
Yeah, so these are the ones that on here are early just mock-ups. We do a lot of single story. This is a split dog house or dog trot house design. So it's got like an ADU attached to a main quarters or like a master suite attached to main quarters. This was for a company that recently sold. So we are still doing a project for this client, but we designed this office space for them before he sold his company. Now we're doing 2 houses for him. They're in permitting on the south side of Bloomington.
Yeah, I love it.
This is where I like to sit and like really nerd out and just swing back to vision. When you ask like why we do this stuff, it's like single family homes are great. I do think this path toward 2/1s, 3/1s, which are attainable by Earth in the Midwest, is the real sweet spot to solving some of our housing crisis. Our city pushed real hard to do quadplexes by right recently. It didn't go through, but our material is uniquely suited to this because of that quiet nature. It outperforms double block, which is the gold standard in STC class ratings. So for party walls, Earth is unbeatable. It's cheap and it provides all those high-end sound blocking characteristics at the best price. And then to go one step further in division, cities and thinking about that scale is where we spend a lot of our like nerd out session. Be like, how do we do this for 500 or 1,000 people at once?
Yeah, I mean, it's one materials giving you all the properties that you need, fire rating, waterproof, I mean, it gives you everything. You don't have to have layers and layers of material, insulation. Is that where the geeking and nerding out comes? Because it's kind of like, well, if one product does it all, why do we need all these other products?
I mean, that's the nerd session right there. Like getting simplicity and elegant design is where we should be pushing. I mean, we have both systems, right? We're getting more complex in the different layers, and you can look like the perfect wall system, which is pushing everything outside, and you're like exposing yourself to framing. There's so many ways to go, but yeah, fewer materials.
Let's talk about the project that you're on now. You sent me some photos. You want me to put those up, and you can walk us through what you're building currently?
Yeah, I'm sitting in part of it, so we can get right into it. Can you flip to the next one where I can see the side?
Let's start here.
Yeah, this one's great. So that double door there on the left, that's where I'm sitting. This is the last tiny house I built for the Carpenter Owl company I ran before.
Wow.
The earth there is on the right. So everything is built in this photo except that part on the right. The basement's where we poured the hydronic floor. And then the top of it will be like a living deck, like a walking deck. This is our first. It's our second permitted structure. Yeah, that's the
hydronic floor there. I want to show it since you brought it up, right?
Yeah. So this is in 3 zones. That's what I'm explaining there. And then you can see it kind of coming up where it's going to be in its wall there. And then we're going to run that upstairs and snake it back and forth through the earthen wall and charge those as well. That's an experiment in part that it will give us like a longer building season, greater control over drawing the walls, and then in the residence, just a real sweet way to heat things.
And so when you say you're going to run the radiant in the actual clay wall?
Exactly. Yeah.
No kidding. So how do you get it, and I know you're going to show us some of this, but how would you even get it into that clay wall would be my question.
So when you're building with earth, you get about 12 or 18 inches of lift a day.
Yeah.
And then the bottom of the wall will start to slump out. That's just where you're bound.
Right.
So each of those layer spots that we stop, we'll just drop a line in.
Excellent. Excellent. All right, so getting back to this structure, this is just some other side and angle views and what you're currently building. How long will it take for this structure from start to finish?
The printing part of it, like I said, 3/4 of it are done now.
Yeah.
The only piece that earthen piece will be printing over the next couple months and shooting turnkey first of the year. We're kind of taking stuff slow and like we're working at anything we run into in this project.
Perfect, perfect. Let's go. You want to go on site and show what we have outside?
Yeah, let me holler out to the engineers real quick.
Perfect. They'll still be able to hear us, but I'm going to blow this up full screen here so people can take a look at it. Walk us through what we're looking at here. And I know it's mobile, everybody, so hopefully it's not too grainy for you.
Yeah, so this is the print gantry head. It's picking up material there in the bottom left, moving it over to that plate you can see on the far right. This is a curved wall that's curving away from us and then going straight down the side. So it comes in, uses its vision to find the material, pops down, picks it up, carries over the wall, and then it does a number of those, comes back, tool change, and then shapes them into the wall assembly.
Got it.
And this material, oh, go ahead.
What's all the QR codes on the ground?
So that's how it finds itself in space. They're April tags, like the name of them. It's got cameras on the bottom mount. It reads those to do its like triangulation in space, and that's how it knows where it's at. So everything in this is driven by reinforcement learning, AI. There's not an operator per se. Like no one's running a joystick right now. The machine is moving under its own accord in this space.
Got it. Got it. So the clay's up there, and obviously this is for demonstration purposes right now, what you're showing us. So that's the pick. Once it places all of the clay on the plate over there, what is next? Do you switch out the from a pick to a hammer, or how does this all work to where it actually puts it together?
Yeah, we won't make the switch over today, but you can see where the knuckle between the machines are. There's 2 pins that pop out, and a different tool goes on. It's a linear hammer about 3 feet long, and it goes around the material and shapes it into the wall assembly.
And shapes it into the wall assembly. And this whole setup is different than a 3D printer. It's not tied to a solid arm. This is a cable system, and I'm seeing the post in the corner. What is there 4 posts, and then you got the cable, almost like you're looking at an NFL camera that plays in the NFL across the field?
Exactly. It's the same type of camera. 8 points connected to 4 towers.
Okay.
And then that keeps it under pressure. You kind of like a little cone that you're working in.
Perfect. Perfect. And can this go all night long? All day long?
We have building restrictions in town for sound, but this machine's quiet enough. We should be able to run 24/7. The mixer might push things. So what we would probably do in that case is mix beforehand, preload the build plate, and let it run all night.
Got it. Got it. This is awesome stuff. Let me go back here so people can watch that while we talk as well. So walk me through the idea of how this works. So that picks and places it, and then you have different pieces that help, I guess, form it on site, and it knows exactly how tall, how wide, how much clay it needs. Is this how you normally feed the machine the clay, or is there like a bigger hopper this would eventually work out of?
So yeah, right now we're still mixing in like a mortar mix style. So it's small batches. At scale, use something like a vertical mixer, and that's doing like multiple yards at a time. But that's when you start to feed onto the plate or feed like a central plate where you're feeding multiple machines at once. So there's a couple different ways it happens, but yeah, you get a higher volume of material at scale.
A higher volume at scale. And then talk to me a little bit about the efficiency of this machine. I know, like, again, where you're trying new things and moving it, but how fast will this speed up, construction in general in your mind once you get it running at full speed?
So the machine itself will probably 2 or 3 times faster than we're seeing here. Where the real efficiency comes in speed is one operator on 8, 10 machines. So then you're getting like doing a subdivision of houses, taking 10 at once.
Right.
That's where stuff gets to really from where you're finishing 1 a week. The wall assembly is a week.
So one wall assembly per week is what you're saying?
If somewhere we're running like even at this speed, if we're
Yep.
building 8 at once over 2 months, then your average is a build week per home.
Sure. Talk to me about the structural load capabilities and shear wall capabilities of building with clay.
So that's a lot of our research has been in getting it to where we don't have to have steel and wood reinforcement. This is the first house that's done in that fashion. We did that by designing it with the engineer who wrote the code. So shear is a definite concern in earth. That's why you'll see in our designs where they're kind of like one-to-one earth blocks. You know, as far as compression goes, the strength in code is 85 psi. Our material with our engineer would keep it 125, far under concrete, but that again, that's per inch of space. So psi, you can argue that like concrete is just vastly stronger than it needs to be to carry the roof load. So we have no problem in compression. You can build an insane column with this stuff, but the shear takes more attention, is where like a lot of our proprietary engineering work has gone into.
So here I want to work with you, Danny. I got a nice big project, right? And outside of a big city, not in the city yet. And I have clay all around me. What do you have to do to know if my clay is suitable to build to the specifications?
There's kind of two paths for that. The nerdy path that we do a lot in the lab is laser sieve analysis, and that's just counting particles by shooting light through water.
Yeah.
Code simply requires test blocks that go to a lab. We run the compression and modulus rupture tests in our own lab, and we verify them with the secondary lab. But that's just making 2 sets of 5 samples, 4x4x8 and 6x6x12, very similar to pouring concrete.
Yeah.
Where they do those little tests for any commercial build.
Got it. Got it. What am I not asking you that you want the world to know here, Danny? I mean, this is definitely something we haven't seen yet on this show, and the fact that it's mobile and can be done on site. And we'll get into what the cost of these machines are, but what is it that you want everybody truly to know about what you're doing and why this is a better way to build?
I think it's just it gets so easy to consider it 3D printing. I think anything that we look at with this sort of technology falls into that framework for the imagination, human mind, however you want to place it. But really, we're just doing what we've done forever with machines. You know, we're just mimicking what humans do with their hands, and I think that's like such a radical leap that it's hard to digest. Where you're like, oh, all you're doing is something we've done forever. So it's like we're not. You know, we're in code. We're not inventing something. It's just making houses like we always made them of cheap materials. And I don't know why I'd belabor it, but that's where it's like even my brain gets stuck on that. It's like we're not doing something new. We're just doing it with a different tool.
Right. I mean, it's true, right? Well, you know, you're doing it with a different tool, but you're putting hydronic heating in the walls. So that's kind of new.
Sure. I mean, adding building science and so forth to it is one thing, but the wall assembly itself is not new. This is something that like a third of the homes in the world are still made this way.
Yeah, yeah. So when you're out and about and you're talking to other builders, what is their biggest question to you?
I mean, a lot of times what you were asking, like, what's the time on a build? And it's right now fairly comparable to a standard house. Other things that might come up is like, how do you attach into it? How do you fasten into it? And it sits in this weird place, and it's something I can't explain unless I bring someone in the lab and hand them a hammer. But it's like driving a nail in a material that's exactly between concrete and wood.
Right.
It like goes in slightly easier than wood, and it doesn't chip out like concrete. And you wouldn't believe it until you do it. So those sort of things where it's like, just it doesn't make sense to people.
Right, right. So as you're digging, like on this project, you said you're doing a little retention pond next to the house, water runoff, right? You build something, you got to collect the engine, the runoff from the new size of the roof you're doing in most places. Is that typically what's happening? Is you're using the soil right next to the building, you're creating some sort of retention pond, or you're taking the material out where you would be putting the foundation anyhow and reusing it? Walk me through what happens with all the material, and is all the material usable?
Once you're down past the organic layer, most soil suitable. We would have used the foundation material from this site, but my house is at the foot of an old farmstead. So when this was replatted, this was an old barn.
Right.
And it turned out there were 2 or 3 buildings on this site in antiquity and at least 1 or 2 burn pits. So nothing was usable below the building. That's why we did the pond next to it. But the point for us was to use the material on site. And to give people context, we're in downtown Bloomington, Indiana. I'm 5-6 blocks from downtown, like the square. So this isn't like happening in the countryside. This is a city-based, code-compliant project, and we're using material on site.
Excellent. Excellent. Let's go to a couple comments here real quick. And not everybody's popping up on the feed. I'm not really sure what's going on. It happened earlier. But Osama Alabi, I was just talking about you, man. World of Smart Homes and our tour through Europe. If you're not familiar with what they're doing, they're using all kinds of clay products and red block solutions. So, but not this way. He says, all the best to you and your colleagues, Danny. Clay is an incredible material. So that's an awesome thing coming from Osama. Smart man. Smart man. Perfect. Let me go in here. We got some more. Greg Ugaldi. I don't know if you know Greg, but he is the past chair of the National Association of Home Builders. DC Live, everyone needs to see this value. Dave and Danny are conduits, PVC tubes, used to preserve access for wiring and ducts within the walls. Excellent. Yeah, so how are you doing the ducts or any of the electricity? Are you using PVC?
We can do both. You can do direct buried line. Anytime you're in the contact with masonry or earth, it falls into that part of the electrical code. A lot of times in Adobe construction, like block Adobe, they'll leave like Smurf tube or other conduit tubes so you can kind of replace things with time. Both systems are options. For us in this particular build, one of the things that's super unique about this house, and if you notice in the images, it's earth over standard Western platform framing, so we can shoot the electrical up just about like any other project.
Perfect. Thank you very much for that, Greg. George Ryman says, great improvement over old Adobe bricks or rammed earth building options. Definitely a need for this in today's world. Man, we need a lot of things in today's world, but this is a great solution for that as well. So thank you. Good to see you, George. Thanks for joining us. Jennifer says, so cool to have Daniel Weddle showcasing how building with clay can solve for sustainability and affordability. Daniel, what else is there, man? I mean, I think this is cool. How do people work with you? I want to do something. Let's go. I need a new studio, Daniel. How do I do it?
So we have a full design team. You come up with a project, we can run through it. We're looking at developers in Texas right now. We're probably going to build in this region in the spring, but looking for partnerships at like 5 or 10 at a time, starting summer of 2025. But yeah, it's pretty much, similar to working with any builder, except for we house our design team and engineers in-house. So we have a lot more ability to go back and forth on design and to make, you send us some blueprints, we'll rework them, and we'll start a conversation.
Yeah. And there's a lot of people watching this right now. So if you're out there and you're watching this, what are your thoughts on this type of construction? We'd love to hear from you as the consumer out there. YouTube's lit up pretty good right now. Clay construction has been around for a long time. It's a healthy material. It's better and breathe than all those toxins we've been breathing all these years from all the homes we've been building, which is the cause of a lot of allergies and migraines, and people don't even know it. So with that said, what's really cool, Danny? You want to come hang out with me in California with all the code officials from across the country?
Oh, absolutely.
If I could say, Danny, Offsite Construction, we're going to do an event that has all the leaders and all the people that write the codes. Well, you have that opportunity now. October 20th through the 23rd, we will be in Long Beach, California for the International Code Council 2024 Conference Expo and Committee Action Hearings. And we've been fortunate enough, Dan, to been asked by the International Code Council to bring the leaders of this industry to them. They want to start hearing what we have to say. They want to start educating. This is where all the code officials from your state, my state, go for their continuing education. This is their national conference. Imagine if you can get everybody from your state in a room, or at least a few of them, to look at it, and you can answer questions. It's a big deal.
Awesome. I'll put it on the calendar.
So put it on your calendar, October 20th through the 23rd in Long Beach. We're going to have some fun while we're out there as well. Danny, man, this has been awesome having you guys on. I know you guys are on site, and I know it became kind of a bit of a like, they're pouring concrete today. But you know what? That's the way it always works, right? It's better than not having your concrete today.
Oh yeah, no, I'm putting dance floors in this weekend because I got a big celebration coming up. I just realized the hammer's back here. This isn't an ad lib thing, but they must have said this so we could see it. So you asked about what the other tools are that go on there.
Yeah, let me blow you up.
This is the linear hammer. So
got it. So that hangs on it just like we saw the pick was hanging, and then that hammers it. That's what gives it compaction.
Exactly, and it turns like a full 180.
Yeah, perfect. Looks like we're freezing up.
Exceeded what I could do by hand, and that's the goal. That finish is good enough that we can seal it and go. There's a lot of sealing options out there that are just market, available.
Yeah.
But the cost in earth is very high if you have to finish. So the goal is this guy leaves it real nice and smooth.
Yeah, for sure. Let me ask you this. In terms of scalability, do you see Tehran also getting into the building product space? Where builders or consumers even could buy a prefab component package kit of parts and put it together. Can I go out and rent this at a local rental store and do this myself?
We just started talking to the first person or two about machines. We're vastly cheaper than most 3D printers, something like 20, 30 times cheaper. So it's possible to start kind of like addressing those markets, machine markets. Right now, our whole focus has been work in the venture capital world and get proof of concept to market where we're GCing essentially for the full builds or getting that plate-to-plate solution. Beyond that, there's a lot of cool stuff that unlocks.
Perfect. Well, Danny, thank you for taking the time, and for everybody that's out there watching this, taking the time. We're not seeing everything come through on the chat side over here for whatever reason, but I know we are live on all those channels. So if we miss something, we will answer it in the comments. But Danny, to you and your crew, man, great work. I love the fact that you guys are trying to build it better, and you're just using what we've always used, but putting a whole new spin on it to make it more productive and more sustainable way of doing it.
Awesome. Thanks for having us on today.
Yeah, you're very, very welcome. All right, everybody, remember, join us in California, October 20th through the 23rd. The International Code Council, the code officials in your state want to see what you're doing. This is a place where they're all coming, and we can help educate them on offsite construction and better building techniques. Because as you can see across this country, the way we have been building isn't working. Too many veterans and too many homeless all over the place and on the street. Danny, don't go anywhere. I'll come back to you after the outro. But for the rest of you, guess what? It's Wednesday. You still got 2.5 more days to keep building it better. Hey, and if you're bored, I bet Danny could use some help on his house as well. So just look him up, tell him you're in the area, and hey, maybe get some free labor. And guess what? You'll get an education. And as my grandfather always said, you can pay to go to school and get an education, or you can try and figure it out yourself and get your ass handed to you. One way or another, you're going to pay to get that education. Danny, thanks so much for joining us today.
Yeah, thanks a lot. And if people want to come out sometime second, third week of September, we'll be having people visit the site.
Excellent. Put it on your calendars. Don't go anywhere, Danny. I'll come back to you after the outro here. And thank you to all of these supporting members of the Dave Cooper Live community as well. Bye now. What an amazing show. Thank you to all of our sponsors for helping us to continue to bring all of these innovative conversations to all of you out there. Please visit them, see what they have to offer you. And as always, subscribe to the YouTube channel and ring that bell. It would mean the world to us. I'm Dave Cooper. Thanks for watching.